Hello students, Calculus 1. Hope you're doing good. I'm going to send you a recording on two problems which a student wanted me, which kind of are tough. So I wanted to show you how to do those problems. The first one, as you can see on my screen, is find the equation of the tangent to the graph of y equals 1/3 of tangent inverse. So it involves inverse tangent function, and the point is given as x equals 4 and y equals pi half. So for the tangent line, we always use, one second. So we use this equation, which is your, we always use this equation, which is your y minus y1 equals m x minus x1, the point slope form of a line. So since the point is given, I can use the point as y minus pi over 12 equals m, which we need to find x minus 4. Now the slope of the tangent is the derivative. So basically, we have to find the derivative of this function. So for the derivative of this function, y prime is 1/3 is a constant. The regular tangent inverse x, if you have tangent inverse x, the derivative is 1 over 1 plus x squared, right? So for this function, it's 1/4 of an x, so I will be doing 1 over 1 plus 1/4 of an x whole squared. Now, since it's not x, it's a function of x, I have to multiply with the derivative of 1/4 of an x. I have to multiply with the derivative of that using chain rule, which is same as 1 over 3, 1 plus 1 over 16 x square right here. 1/4 square is 1 over 16 x square. And the derivative of 1/4 of x is your 1/4. So it boils down to 1 over 12 if I combine 1/4 and 1/3 together, which is 1/12. And I can leave like this, 1 over 1 plus 1 over 16 x square. I need the slope at what point? I need the slope at at x equals 4. So just plug in 4. So if I plug in 4 here, which is 4 square, this cancels, right? So I'm left with 1 over 12 and 1 over 1 plus 1, which is 1/2. So 1 over 12 times 2, which is 1 over 24. So the slope right here in the equation of tangent right here is 1 over 24, right? So your equation becomes y minus pi over 12 equals 1 over 24 x minus 4, or which is 1 over 24x minus 4 over 24. I'm distributing 24 plus pi over 12, which is same as 1 over 24x minus 1/6, 4 times 6, plus pi over 12. So that's your, the last one is your equation of the tangent line, and it matches the answer right here, which is 1 over 24x minus 1/6. This is negative 1/6, this right here, right? Plus pi over 12. So that's the first question. Let me move to the second one. I'm going to close this one. So the second problem was, let me see. Okay, so let's look at the second problem. As you can see on the screens, that's your second problem, which involves the exponential functions. Sin x to the natural log of 10x, a equals pi half. So you have to evaluate the evaluate the derivative at a equals pi half. So there are two different ways of doing it. I usually, whenever I see a function of x in the exponent, I use natural log on both the sides. So I'm going to rewrite my function as y equals, let's see, one second. I'm going to rewrite as y equals sine of x, right, ln 10x. So since I see an x in the exponent, I'm going to use natural log on both the sides. So using natural log on both the sides, natural log means ln on both sides, what do I get? I get ln of y equals ln of whatever your function is given, all of this right here, right? But there is a property of natural log that, which I'm going to use here, that natural log of a to the r is r natural log of a, right? So the exponent comes up in front. So exponent means this exponent right here. So my function is right here, which is sine x, and raised to the ln of 10x. That's my exponent that comes up in front right here. So my function changes to ln of y. Left side is ln of y. Right side is natural log of 10x. It's my r, it's my exponent, and ln of sine x. Right? Now you want to find the derivative of this function. The derivative of ln of y is 1 over y prime, using chain rule, implicit. On the right side, it's the product rule. It's the product of two functions. If you see here, this is my f and this is my g. So it's f prime g plus fg prime. I'm using my product rule, which is same as ln of 10x. The derivative is 1 over 10x, but since this is a function, I have to multiply with the derivative of 10x, right, which is 10, and I'll keep ln sine x as it is, right, plus ln of 10x as it is. The derivative of ln of sine x, 1 over sine x, times the derivative of sine x using chain rule, which is same as 1 over 10x times 10 times ln of sine x. The derivative of 10x is 10 plus ln of 10x times 1 over sine x times cosine of x. The derivative of sine is cosine. So this 10 and this cancels. I'm left with 1 over x ln sine x, right, plus ln 10x times cotangent x. Sine over or cosine over sine is cotangent, which is same as, now this is same as 1 over y prime. I'm interested in finding y prime, so I multiply by y on both the sides, which is your function, which was sine x raised to the ln 10x, and then inside is all of this. Inside is all of this, which is right here. All of this goes right here. So that's your derivative. Okay. Now to evaluate it at pi half, you have to plug in pi half everywhere. So let me rewrite the derivative and then plug in pi half. So 1 over x ln sine x plus ln 10x cotangent x. So that goes for the derivative. Now to find at a certain point, I would be plugging in pi half. So plug in pi half here. Sine pi half is 1. 1 to the any power is 1. So this is 1. Now this is 1 over pi half. Ln of sine pi half. Sine pi half is 1. Ln of 1 is 0. So times 0. Plus ln of 10 times pi half. Cotangent of pi half is 0, which is 0. So 0 plus 0 is 0. Times 1 is 0. Okay. So that's your two questions. Go over them. Exam starts after the spring break. Hope you're having fun. And I won't be able to answer your emails anymore till the end of the spring break, till the 18th. So I mean, you can send me an email if it's something urgent. I can respond. If it's not, then I'll respond after the spring break. So take care and enjoy your spring break. Bye-bye.